For this example, you're going to be filling in the chart with the missing parts. So for this first piece here, the initial value, remember, is the number in front. So our initial value on this one is 25. If I notice the inside of the parenthesis here, that's your a value. Remember, it's y equals c a to the power. Our value here is less than 1, which means that we're looking at a decay problem. We're multiplying our number 25 times a number less than 1, so it's going to go away eventually. The growth or decay factor, all right, that's the a value, and that's the value that you see in the problem. So our factor that we're multiplying by is 0.05. The rate, though, that depends on whether it's a growth or decay. So our formula for that is, and we had it back earlier in the worksheets here, that a equals either 1 plus the rate or a equals 1 minus the rate, and the rate has to be written as a decimal. So if we're talking about decay, that's when we subtract, and I know what my a value is. So 0.05 equals 1 minus r. Subtract 1 from both sides, and here's where you can use your calculator if you need to, but it's going to be negative 0.95 equals negative r. There's still that minus in front of the r, or r equals positive 0.95. So we have it as 0.95, but convert the decimal to a percent. You times it by 100, and you get it decays at a rate of 95%. Okay. These other ones you kind of have to think about and figure a little bit. So for this one, let's just call it y equals. Our initial value is 300. I'm told what the factor is. That's what you're multiplying by. So I have my equation raised to the x power because it's an exponential function. Because this number is bigger than 1, we're looking at a growth now. Okay. So for this one, since it's a growth factor, we're going to use this formula for growth to find the rate. So again, my a is 1.14 equals 1 plus r. Subtract 1. R equals 0.14. So 0.14, or if you multiply that by 100%, it becomes 14%. What you're doing is multiplying by 100% and then putting in the percent symbol. Okay. On this third part here, I know the initial value. Notice you're either told what the initial value is or you're given the equation. So the initial value has to be somewhere in the problem. So our initial value of 54, it's a decay. So I know that whatever I put in here is going to be less than 1, but I'm not told the factor. This time I'm told the rate. And 85.6% is the same as 0.856, and I'm looking at decay. So the decay formula was this one up here, 1 minus r. This column is r, so my a equals 1 minus 0.856. Right, so with your little calculator here, 1 minus 0.856, 0.144. This is the number that goes right in the parenthesis here. so 0.144. Okay. Let's try this next one here.